Hi, hello guys. It's Tekiso once more, man. I'm gonna take another different problem on mechanic of machines. Uh, someone was crying foul to say I'm ignoring some problems because I see them as easy, and to them they are very difficult, and they will suggest that I do that problem. It's a problem of V belts where you calculated the number of belts used to connect those two pulleys. It says what? It says a light pulley has a diameter of 320. A light pulley. Let's say, for instance, it does this. For now, this is a pulley, guys, and then this is our belt. It's something like this. You know, we treated these things where maybe a pump is being installed there, and then as it provides power to this driver, this belt transmit power to the next pulley. We did those. It's just that it's long time ago, and I've just started with problems. It says a light pulley has a diameter of 300, which is 0.32 meters. I just converted millimeters to meters. A light pulley has a diameter of 320 millimeters. The grooves of an included angle of 40. The grooves of an included angle of 40. What does that mean? It means beta is equals to the half of 40. We proved this. We proved why is that. I'm gonna do it again probably in the next video, but for now let me tell you, if you've got E exponent coefficient of friction theta cosec beta, this theta here is in radians, and then this one is beta. It is in angle. It is in angles. Now this, if the problem says an included angle of 50, beta is 25, an included angle of 40, beta is 20, an included angle of 100, beta is half of that, and so on. Now this will come later to it, but this is the case. And then a belt contact angle, this angle there where the belt touches the pulley, this angle there, they say is 190, and meaning 190, we said it is in radians. It's equals to what? It is equals to 190 multiplied by second function pi, and then we divide it by 180. It's equals to 3,316. 190 second function pi divided by 180. Yes. And then calculate the number of V belts denoted by the symbol N is equals to question mark required to transfer 50 kilowatts, the output power of 50 kilowatts, the transferred power, when this pulley rotates at 1600 revs per minute, and you are told that the coefficient of friction between the pulley and the belt there is equals to what? Is equals to 0.3. And the maximum tension in each belt, is limited. This is T1. It is limited to 600 Newton. Straightforward. This is a very, very straightforward one. But first of all, let's see. We've got already our 190 degree angle in radians. Let's convert this let's convert this. Cosec beta from the basic mathematical trigonometric identities. The inverse of cosec is equals to 1 over sine. And you are told that an included angle of 40. And we told that beta is half of that 40. And it's equals to what? It's equals to 1 divided by sine of 20 is 2,9 2,924. This one. Therefore, E mu theta cosec beta is equals to E, this coefficient of friction is 0,3 multiplied by the included angle of 3,316 multiplied by cosec beta is okay, let me put it this way, guys. I apologize. It's cosec, sorry, is E mu theta cosec beta is equals to E 0,3 multiplied by theta in radians is 3,316 multiplied by cosec beta, which was calculated and found to be 2,924. And it's equals to what? It's equals to second function ln of open bracket 0.3 multiplied by 3,316 multiplied by 2,924 closing brackets. Answer. We have how much? Yo, why such a big number? We've got 18,335. Yeah, it should make sense because we got an inverse there. Yes. And then now that we've got this, we also got power. What else? We are required to calculate what? The number of V belts. We've got this. We've got power as well. We've got that. Now, I will say T1 over T2 is equals to E mu theta cosec beta, which is equals to this is found to be, okay, let me say 600 over T2 is equals to all this. It was calculated and found to be 18,335. Therefore, T2 is equals to 600 divided by 18,335. And it's equals to what? It's equals to 600 divided by 18,335. Answer. The tension on the slack side is equals to 32,724 Newton. Now, are we requested to calculate the velocity? Yes, let's calculate the velocity there. The velocity will be pi dn over 60. These are formulas from sub A. We all know them. And it's equals to pi multiplied by the diameter of 0,32 multiplied by the speed, the rotational speed of 1,600 over 60. And it's equals to what? It's a second function pi multiplied by 0.32 multiplied by 1,600. And then we divide it by 60. We get 26,808 meters per second. Meters per second. And it's equals to what? Power is equals to the effective tension. which is T1 minus T2, multiplied by velocity, multiplied by the number of belts. And you were requested to calculate the number of V belts connected, that should be connected to the grooves of these pulleys. And it's equal to what? You are given an output power of 50 exponent 3 divide by what? Let's divide already. You were trained during your high days of school as to how to manipulate to make something subject of the formula. You can't have a problem there. This is equal to what? This is equal to 600 minus 32,724 multiplied by 26. Velocity, linear velocity 808 is equal to what? Is equal to the number of belts denoted by the symbol N. Therefore, let's say 50 multiplied by 10 to the power 3 divide by 600 minus 32,724. Answer, let's say it's 567,276 multiplied by 26,808 is equal to the number of belts. Therefore, N is equal to what? The number of V belts that should be connected to that pulley. It will be 50 exponent 3 divided by open brackets 567,276 multiplied by 26,808 closing brackets. Answer, you've got 3,287. Now you've got this. After getting this, if you were requested to calculate the number of belts, you don't mathematically say this is less than 5, therefore it's just 3. If it's 3,123, you can't use 3.5 belts. You round them to the next value. So because it's 3 something, the number of belts, you will say 4 belts. 4 belts. If it was 2,014, you will say 3 belts, and so on. This is the number of belts required to be used on this on those two pulleys. On those two pulleys. Hey, gentlemen, please, man, keep on sending those. I've seen we've got a lot of problems. People were posting as to we should do this, especially on strength of material N5, but we are coming on those ones, and then we're gonna do insulators and so on. Mr. Chester, I don't know whether I should do the next problem or this is fine for I think it's fine. Or can I continue? Should I add another problem on this? Yes. Okay, let me add. I'm told that I've still got to say roughly 15 minutes. Yes. 15 minutes. Let me finish it. Let me do another one. Then I know, man, we have covered all the V belts, all the belts. Or then I will say maybe we are left with the one maybe where maybe you are required to calculate the length of the belt. The length of the belt. But listen to this one. It says 2 identical double grooves. You must listen to, actually you must practice so that when a problem arises, you know. 2 identical double groove pulleys. What does that mean? They are telling you already that the number of belts that has been used on that particular problem is 2 of them. Why? Because each pulley has 2 grooves. So each groove put in 1 belt. They are telling you that N is equals to 2. N is equals to 2. They are telling you that N is equals to 2. n is equals to 2. Double grooves, n is equals to 2. With an included angle of so much. Remember, beta is half of 48. Included angle of 48. Beta is equals to 24. We explained that initially. Have an effective diameters. The diameters of those two pulleys are equal. If the diameters from here to there is equal. These two pulleys are equal. They've got a diameter of 0.3 meters. Let's see. And they are mounted on the parallel shaft. They operate at the same speed. That's what the statement says. Each V belt has a cross-sectional area. Area of 750 millimeters squared. It's multiplied by 10 to the power minus 6 meters squared. Conversion, simple as that. And a maximum allowable stress of 9 megapascals. The belt density is 1250 kilogram per meter cube, and the coefficient of friction between the belt and the pulley is 0.25. Now they say calculate the power delivered to the driven pulley when the driving pulley rotates at 600. The driving pulley rotates at 600 revs per minute, and the belt slip at the driven pulley, driven pulley is equals to 6%. 6%. No, very extra important. Very important. But let's see, guys. Let's see. We calculate the power delivered. We've got the area there and the stress. We can calculate the force, which is what? The force, which is the maximum tension. The maximum tension is equal to what? Is equal to the stress multiplied by the area. And you are given the stress of 9 multiplied by 10 to the power 6 multiplied by the area. Let me take the area is 750. 750 multiplied by 10 to the power minus 6 meters squared. And it's equals to what? It's equals to 9 exponent 6 multiplied by 750 exponent minus 6. Answer 6750 Newton. This is the tension on the tight side of this particular pulley, like this, for instance. This is that force, and then this one is yet to be found. Okay, right. We've got now this. We've got what? We've got this, the tension on the tight side. And what else? And then the belt material has a density. What does that mean? It should mean only one thing. You know from high school or from sub A, if my memory serves me well, that density is the ratio of mass to volume. Therefore, the mass is equal to what? The mass is equal to density multiplied by volume. Actually, it's area, but for now, I will show you how to make your life easy. So, the density is given as what? The density is given as 1250 multiplied by volume. volume is equal to area multiplied by length. So we use 1 meter of length. So is this multiplied by, what is the area? The area is 750 multiplied by 10 to the power minus 6 multiplied by 1 meter, or one width of length, and then is equals to 1250 multiplied by 750 exponent minus 6. It is equals to what? 0.9375 kilogram per meter of length. Kilogram per meter of length. You know, we've been saying that all this time. Now then that the mass have came out and play itself out. What does that mean? We have to calculate the centrifugal tension, which is M multiplied by V squared. But now we don't have V. We don't have V, but we are given what? We don't have V, but we are given 600 revs per minute. Calculate the power delivered when the driving pulley rotates at 600 revs per minute, which is equals to pi multiplied by the diameter was given as 0.3. Am I right? Yes, 300 millimeters, which is 0.3 multiplied by 600 divided by 60. And it's equals to what? It is equals to second function pi multiplied by 0.3 multiplied by 600. Let's divide that by 60. We've got 9.425 meters per second. Now that velocity, we've got 0.9375 multiplied by 9.425 is equals to what? It will be 0.9375 multiplied by 9.425. Answer. We've got what did I do here? 0.9375 multiplied by 9.425. Answer. You've got 83. Am I right there, Mr.? Second function pi multiplied by 0.3 multiplied by 600 divided by 60. Yes, 9 comma that this is equals to that. It's fine. Let's take it 1250. 1250 multiplied by 70 exponent minus 6. 0.93. This multiplied it together. 0.9375 multiplied by 9.425. Answer. It says 8.83. Why so low? Oh, okay. You see why low? You must always try and accommodate mistake, check them and grow for the better. I forgot to square this velocity there. To square that velocity there. That's where my problem was. Meaning is 0.9375 multiplied by 9.425 squared. Answer. It's 83.279 Newton. Now then that we've got this, what does that mean? It means to calculate T2 is T1 minus T, this TC must be included over T2 minus TC, which is equals to E mu theta. Yes, that's it. Or it's a V groove. Yes, it's a groove, it's a V groove. Cosec beta. But what is cosec beta? It has an included angle of 48. Cosec beta is equals to 1 over sine 24. and it's equals to what? 1 divided by sine 24 is 2,459. 2,459. We are not given, meaning we are not given an angle of contact, meaning the belt comes out at 100, at half of this, and then it enters there. It means at 180. So this is gonna be pi. You don't have any included angle there, so it's pi there. So this is what? This is E is given as what? Coefficient of friction is given as coefficient of friction. Is it given? It's not given. It's given. Yes, it's given as 0,25. 0,25 multiplied by pi multiplied by, this was calculated to be and found to be 2,459 is equals to what? Second function ln of 0.25 multiplied by second function pi multiplied by 2,459 closing brackets. Answer, this is 6,898. Right. Now this is given. It was calculated and found to be 6750 minus TC is 83,279 over T2 minus 83,279 is equals to what? This was calculated and found to be 6,898. This, it is dead. Now 6750 minus 83,279 is 600 is 666,721. Let's cross multiply. We're gonna have 6,898, and then we've got T2 minus 83,279. Right. We can divide by this. We can say 666 that, 721 divide by 6,898. It's so much. And then we bring this on the far side. We add plus 83,279. Answer, I will say T2 is equals to 1049,75 Newton. That's T2. But we are requested to calculate what? Calculate the power delivered. We've got this, we've got that, we've got velocity, we've got the number of V belts. Okay, right. Where can I erase them? Let me erase here. Therefore, the power is equals to T1 minus T2 multiplied by velocity multiplied by the number of V belts. The two identical double grooves is 2 there, and it's equals to what? This, it was calculated and found to be 6750 minus T2 was found to be 1049,75, and then we multiply by the velocity of 9,425 multiplied by the number of double grooves, the number of belts. So it's equals to what? It's equals to 6750 minus 1049,75. Answer, multiply by 9,425 multiply by 2. Answer, we've got how much? Is 10,749,713 watts, which is 107,449 kilowatts. All right, fancy kilowatts. Now Mr. Chester, as I come to a close, I will say you are told that there is a slip at a driven pulley. There is a slip of 6%. What does that mean? The efficiency of this transmission is 100% minus 6%, which is 94%. The efficiency, which is 94%, is equals to the output power over the input power. This 107, it moves from the driver. That driver put it in at the driven. So this, it is the input to that pulley. So you've got an efficiency of 94. If I divide it by 100, it's gonna be 0.94. That's where Mr. Massimo's problem was. Nothing else. There's nothing special about this problem. 0.94 is equals to the output over the input. The input to the driven pulley is equals to what? 107.44. Remember, an output of the motor, this is the input of the motor, the output. This output of the motor, it is the input to the belt. And then that output is driven to the driven pulley. It is actually transmitted to the driven pulley. This output there is gonna be the input to that one. That's the only thing what that statement says. Now the output, the delivered power, the output is equal to what? It will be 0.94 multiply, I've just cross multiply, 1 multiply by 107.449. Answer 101 kilowatts. Mr. Chester, they must get 101 kilowatts there. I'm right?
Yes.
Yeah, the 101. Exactly. That was the only cache. Hey guys, please man, just keep on practicing this problem. There are difficulties being a while, but they should make sense.
Since the answer is
101,
exactly, can you please just erase the bottom part so they can see?
Oh, okay.
If ever they're taking notes, so
yes. Okay, Mr. Chester was saying that is not to confuse you. This is actually the answer. Hey guys, I will see you in the next video, but please, with due respect, just subscribe, spread this video. I will see you next time.
Thank you.